Finally, we can cross over into more complex data structures. Lists are just one type of data structure that we will study. Think of lists as a form of packaging, like Oreos that fit into nice rows. Well, one row enclosed by square brackets is a list. In it, you can fit anything from integers to strings and even maybe Oreos. You can even stack rows and get a 2D chart form. It's super easy to access these too. Remember the for loop? You can nest the for loop to stay in bounds within the lists and access each individual element, just like a vending machine, using rows and columns. Lists are represented by brackets. To declare a list in Python, all we have to do is define a list with a name and put things inside of the brackets. And this is what the list stores. If you put nothing in a list, you will have an empty list. We can say list1 equals some things inside of brackets. And since this is empty, there's nothing inside list1. Alternately, you can do list2 equals bracket, and you can put things like integers inside of it. You can also put things like strings inside of it. You can even put booleans, so true, false, like we have done before. To access any element, all we have to do is find its location in the list. In any list, the first element is spot 0, and the last element is the total number of spots minus 1. Make sure you're careful when accessing lists, because if not, you could go index out of bounds on a list, which is not good. So if we take this case right here, A is in slot 0 in list 2, B is in 1, and C is in location 2. The total length, of course, is 3, and the last index, of course, is the length minus 1, which is 3 minus 1 equals 2. Make sure you never go to length 3, or you come here, which is an out of bounds error. Let's write what we did before into code. Lists can store strings, ints, booleans, and even mixes of these and other data types. Let's say we want to create a very simple shopping list, so this would happen to contain strings. We can call the list list1, and inside the brackets we simply put the strings that we want the shopping list to store. In this case, let's say we're shopping for fruits. We got apple, banana, and cherry. Accessing lists this way, we can add things and change things inside the list. And to quickly access or go through the whole list, we can even integrate loops like we did before. Either a for loop or a while loop would work. For example, in here, for, let's say, element in list1, we want to print that element. So element is going to be apple, then banana, then cherry, and it's going to print it out for us. So let's give that a run. And that is exactly what it gives us, apple, banana, cherry. Lists even have their own built-in pre-written functions. That means you don't have to write it in, as it's already in Python, like the math library. One function is length, which we see how big it is. So here, let's say we want to find the list of the length. As we talked before, there are 3 elements, so the length of this list is going to be 3. Another function is type, which describes what list1 is. Perhaps we don't know what it is, so we just use the type function and put list1 inside. And if we print it, it will tell us that list1 is indeed from the Python class of list. It stores strings. Another thing you can apply to lists is the reverse function. If we do list1 dot reverse with parentheses, it will reverse this list for us. If we print it out, it should give us cherry, banana, then apple, which is what it does here. It has reversed list1 for us. And a final thing we'll try out is clear. Let's say you want to get rid of the shopping list. Then you can just hit dot clear with parentheses, and then if we print it again, our new list that it prints out should be completely empty. It has nothing in it, which is what it gives us. As you can see, just plain normal brackets. And there are tons of other methods that are built in that you can use for these as well. One example would be count, which returns the number of elements with a specified value. Let's say you want to see the number of apples and number of times you wrote apples inside of this list. Then you could apply the count to the element of apples. There's also index. Index returns the index of the first element with a specified value. Say you put like apples 5 times, but you want to see where it first appears on your list, the position of it. There's also insert, which adds something to a specified position. Say you forgot to add oranges. So using the insert method, you can do that as well. There's pop, which removes the element at a specified position. You temporarily take it out to look at it. There is also remove, which takes the first item of the specified value completely out. Let's say you don't want cherries anymore, so it'll take out cherries for you. And then there is even the sort method, which should sort the list for you alphabetically, or if you have integers, in an order from least to greatest. So that can be helpful as well. Really encourage you to check out the Python list documentation, as it has all the possible things you can do with the list data structure. So we've talked about lots of them. Let's actually try to implement them. In the first case, we do count. We want to count how many times we created this new list, since we just cleared it before that apple appears. In this case, we added apple 2 more times because, I don't know, maybe someone's forgetful and they wrote apple too many times on their shopping list. And if we try to print this out, it should give us apple with a count of 3, which is what it gives us here since it ran 3 times. We can try the next one, index. We want to find the first time we wrote apple on the list. As we can see, it happens at index 0, so it should return us 0, which it does for us here. Next one, insert at index 3, which is what this tells us, and we want to put in grapes. So 0, 1, 2, 3, it will put grapes before this apple and shift everything out right after that. None, that means it has done it for us. And real quick, we can do print the list to see the new modified list. As you can see, it has shifted the apples and put in grapes for us, which is nice. Then we can also pop a specific index. That means temporarily remove banana for us if we want to see what's at index 1. Continuing, let's try out pop. Pop is going to pop or take out a specific object at a specific index. So pop 1 is going to take out 0 index, 1 index. It's going to take out banana for us, and if we print it, it will actually return banana for us. We try that out. Yep, it returns banana for us. That's this first line of code, and the list has been modified to take out banana. After that, we can try remove. Remove is going to take a specific object out, the first instance of it, out of the whole list. So if we remove apple, it's going to take the apple at index 0 out, and this will print out for us the apple gone. Banana was already removed previously, so now it's just cherry, apple, apple, which is what we have here. And finally, we can try out sort. As we talked about before, sort is going to give it back to you lexicographically or in an increasing order for integers. So if we sort this remaining list and print it out, it should give us apple, apple, cherry in alphabetical order, which it does right here. So as you can see, lists are pretty versatile with a variety of functions. There are other collection type data structures like tuples, which are just like lists, but they are unchangeable, so you can't modify them. Sets are like lists too, but with all the duplicates removed and non-indexable. Dictionaries are, well, like real dictionaries. They have a key, which is the word, and a value, which is the definition. As a final note, lists are pretty rigid. It's hard to insert, remove, or even add things to the end without altering the overall size or other elements in the list. In more complicated data structures like stacks and queues, there are further options that allow you to insert, remove, append, see if an element exists in the list, and find the index of an element, in addition to changing values, of course. Thanks so much for watching. Make sure to like, comment, subscribe, and share with your friends. Until next time.